This is Tech Math 3. No, it's not. This is Tech Math 2, and we're in sections 11.1 and 11.2 today. And section 11.1 has to do with the law of sines. And so we have a rule, law of sines, which is in the first front cover of your book. So if you forget what it is, you can always look. A over sine A is equal to B over sine B is equal to C over sine C. Now the first thing we look at that, we notice that it violates all the rules of ninth grade algebra we ever saw. I can't have three equal signs like that. That doesn't make any sense. So the truth is either those two guys are equal and he is not, or those two guys are equal and that one's not, or these two guys are equal and the guy in the center is not, but they can't all be the same. So even though we have an equal sign saying they're all the same, they're not really all the same. All right, so what is this trying to tell us? Well, if I have a triangle and I mark it A, B, C, and then across from the angles I make it A, B, C with little letters. And then I go and I draw a altitude here, which is a right angle guy coming down, and I label him H. What can I say about the angle B? Okay, well, the only thing I can say about the angle B is that the sine of B is going to be H over A. Sine of B, H over A. What can I say about the sine of A? I can say the sine of A is H over B. I could do that. Well, if I did, then I could say, well, H is equal to A sine B, and I could say H is equal to B sine A, and because these two H's are the same, because it's the same H in both cases, then A sine B has to equal B sine A, and then I could write that as A over sine A is equal to B over sine B, and I'd be perfectly okay. But in order to go and get the other guy, I got to throw in an altitude someplace else. So I'd throw in an altitude, I'd construct an altitude that way, H prime, and then I'd end up with a different answer for H prime because it's a different thing. But in any event, the thing to take from it is that if I have A, B, if I have three of the four A, B's, then I can solve the other part of the equation. So before this point, we were stuck with solving right angles all the time, right triangles all the time. Now we can, with the law of sines, we can solve triangles that don't have the same. Now, what happens if I know angle A and I know angle B and I know angle C? Can I use it in there? And the answer is no, I can't, because now I have two answers and two unknowns. I have two answers and two unknowns. It won't work. And if all I know is the angles, how can I possibly know what the sides are? Because I can draw similar triangles all day, and I have an infinite number of them. Without knowing one of the sides, I won't be able to solve that triangle if I have angle, angle, angle. What if I have two angles and the side opposite? So there are going to be cases where I'm not going to be able to solve. We have another set of rules on page 375, and it says that if I only know 1 degree, if I only have 1 degree of accuracy, then the best I can do is 2 significant digits in my answer for lengths. And if I'm 1 minute, then I can have 3 significant digits. And if I'm 1 second, then I can have 4 significant digits. So that's always good to know too, that we do have some rule about significant digits when we measure these angles. Okay, the triangle is always going to be in standard position. A, B, C, A, B, C, and we're always going to solve it that way. That's what we're going to do. There's going to be a time when I might have more than one answer. So I could have a triangle that looks like that, or looks like, well, that's not good. Looks like that. I could have multiple triangles, or I could have a triangle where there's no answer. So I could have a triangle where it didn't, the third side's not long enough to hit up with the first side, and I'm not going to have an answer. Those will be cases that we handle today in section 11.2, where we have an ambiguous case, and later on where we have no answer at all. Okay? Any questions about that? That being the case, we'll start with number 3, and we'll draw a picture, and we have A, B, C, A, B, C. Okay, and we know that angle A is 69 degrees. We know that little a is 25.0 meters. And we know that little b, way to go, Doug, you put them in the wrong spot already, is 16.5 meters. So first thing we'll go for is the angle A. So I've got 25 divided by the sine of 69 is equal to 16.5 divided by the sine of B. What?
You're doing 3?
I think. Well, maybe not. Guess I'm doing 1. Am I doing 1? Said I was doing 3, but I think I'm doing 1. Okay, well, from here we can deduce that B is going to be the arc sine of, okay, that's going to go on the other side of the equation. I'm going to have 16.5 times sine of 69 divided by 25. And we take out our calculator. Arc sine of 16.5 times sine 69 divided by 25. And I end up with 38 degrees. Okay, so now I know that B is 38 degrees. I also know what C is, right? Because the sum of the angles in a triangle is 180. So if I take 180 and I subtract 69 and I subtract 38, I end up with 73 degrees. So I know that C is going to be 73 degrees. And then I want to find little c, so I say, well, sine 25 over sine 69. We always like to use the given part of the problem and not a calculated part of the problem to find the next answer, divided by the sine of 73, implying that C is equal to 25 sine 73 divided by sine 69. We put that in our calculator. 25 times sine 73 divided by sine 69, and we end up with 25.6. And we ask ourselves, do we have units? Yes, we do. Meters. C is equal to 25.6, and then we'd write a final answer on the side someplace listing all those things. But in order to come up with all six, now we'll do number 3. And I put a triangle. Well, you know, I could probably go get, I'll do that next time. I'll get a different triangle. Okay, so I got A, B, which we know is 61.4. Way to go. Degrees. And we know little b, 1, 2, 4 centimeters. And we know C, 112 centimeters. Now, an idiot check tells you that the guy with the longest side is going to have the biggest angle. So because the B guy is 124 centimeters, 61.4 is the biggest angle I can have. Well, not necessarily, because this angle might be bigger than 61.4. But B is going to be bigger than C, so that answers that. Okay, well, I guess the first thing we're going to do is find C, capital C. So 112 divided by the sine of C is equal to 124 divided by the sine of 61.4. So C will be the arcsine of 124 times sine, sine of 61.4. As I was saying, 112 times sine of 61.4 divided by 124. Did I do the cross multiplying right this time? Yes, I did. Okay, that's fine. Sine, arcsine, 112 times the sine 61.4 divided by 124, put in enough parentheses, and I end up with C being 52.5 degrees. All right, so C is 52.5 degrees. I can now find A. So 180 minus 52.5 minus 61.4. And that was only Benjamin coming into the room, so it's not that big of a deal. 66.1 degrees is A. Okay, so now I've got A. Now I've got to find little a. All right, so little a divided by 66.1, the sine of 66.1, is going to equal 124 divided by the sine of 61.4, implying that little a is equal to 124 times the sine 66.1 divided by the sine of 61.4, and we find little a is going to be 129.1 centimeters. 129.1 centimeters. And the guy with the biggest side is the guy with the biggest angle. So idiot check says that that's okay. Okay, we're going to do number 12 next. And we've got A, B, C, little a, little b, little c, and A is 35.09, and B is 48.64. All right, and we have little a is really 8.362 kilometers. So we get a 4.0 for writing the problem down right. Okay, first thing we're going to go for is the low-lying fruit, which is the angle C. So 180 minus 35.09 minus 48.64 and 96.27. 96.27. All right, then we'll go and find little b. So little b divided by the sine of 48.64 has to equal 8.362 kilometers divided by the sine of 35.09. And if we don't put a degree mark there, that means we're talking about radians, so we better put a degree mark there. So this is implying that b is going to be 8.362 times the sine of 48.64 divided by the sine of 35.09, and I end up with, really? You gotta be kidding me. That can't be right. I wonder if I put it in right. Anyway, my answer says 8.325 kilometers. That seems wrong, because B's got to be bigger than A, because B is the bigger angle. Okay, so what did I do wrong? Okay, so we'll clear out the calculator. B, little b, A, little a. 8.362 times the sine of 48.64 divided by the sine of 35.09. Oh, much better, much better. Okay, so 10.92, and that'd be 1, 2, 3, 4 significant digits, kilometers. So B is 10.92 kilometers, and then we got to come up with little c. So little c over the sine of 96.2. 96.2? 92.7. 96.27. Is that better? Is equal to 8.362 divided by the sine of 35.09. All right, so little c is going to be 8.362 times the sine of 96.27 divided by the sine of 35.09. And we'll call it 14.46 kilometers to keep my 3 significant digits. So this guy is 14.46 kilometers, and then we'd call that a good answer. All right, next is 19. Oh, wonderful. Just plain wonderful. Degrees, minutes, seconds. Just what we need, right? All right, so A is 31 degrees, 14 minutes, 35 seconds. And B is 85 degrees, 45 minutes, 15 seconds. And little c is 4.575 miles. Only a surveyor would like these answers. Okay, so I would go 180 minus 31, hit the math key, move over to degree, minutes, seconds, hit the 1 button. 14, hit the math key, move over to degree, minutes, and seconds, hit the 2 button. 35, hit the math key, move over to degree, minutes, seconds, hit the 2nd button. And then say minus 85, math, degrees, minutes, and seconds, degrees, 45, math, degrees, minutes, and seconds, hit the 2 button. 15, math, degrees, minutes, and seconds, hit the 3 button. Now there's other ways to do it, but why not let your calculator tell you the answer? So C, this is the B guy. So C is going to be 63.0027 repeating degrees, and of course we want that to be in degrees, minutes, seconds. All right. So we're gonna subtract 63, and then we're going to multiply our answer by 60. Okay, and we're going to see that we don't have any. How can we not have any? Yeah, we don't have any, because we have 45 and 15 is close to, we're very close to having a whole second left over there. All right, so we're going to multiply it again by 60, and I'm going to get 10. So I got 16, 10. And then I say, well, 10, 35, 45, 15 is 60, add 1. 45 and 15, add 1. Yeah, that makes sense. Okay, so I've got 63 degrees, 10 seconds. Okay, that's what I got. That's what I'm sticking with. Now I got to come up with little b and little a, the sides. All right, so we'll look at a divided by 31 degrees, 14 minutes, 35 seconds is equal to C, 4.575, divided by the sine of, I have to do the sine over here too, sine of that, sine of 63 degrees, 10 seconds. All right, so now this turns into a calculator problem. Can I do that? 4.575 times the sine of 31 math over to degrees, minutes, seconds, 14 math over to degree, minutes, and seconds, 35 math over to degrees, minutes, seconds. Oh, bummer. I hit the enter key. Okay, that's fine. I hit the enter key. Okay, so I'm going to divide my answer by the sine of 63 math, degree, minutes, and seconds 1, 10 math, degrees, minutes, and seconds, close parentheses, equal. Syntax error. So I probably have to put in 0 seconds, 0 minutes. Yeah, you got an answer for it? So Nate's going to tell us what the answer is. We'll set up B. So B divided by the sine of 85, 45, 15 is equal to 4.575 divided by sine of 63, 10. The other thing we can do is change the degree, minutes, and seconds into a decimal number and use the decimal number. You got an answer for Nate?
Yeah, 2.663.
2.663 miles. Okay. So now we're going to do the B guy. 4.575. Clear my error. Oh, wait a minute. I can put it back in my calculator. Insert 0, math, degree, minutes, seconds. Boom. Yep. Yep, that's exactly right. So I didn't have to re-enter it all. I could just go put back the thing. All right, back to what we're doing. 4.575 times the sine of 85 math, degrees, minutes, and seconds. Boom. 45 math, degrees, minutes, and seconds. Seconds. 15 math, degrees, minutes, and seconds. Seconds. Close parentheses, divided by sine 63 math, degrees, minutes, and seconds. 0 math, degrees, minutes, and seconds. Minutes. 10 math, degrees, minutes, and seconds. Seconds. Close parentheses. Boom. I have 5.120 miles. And then I asked myself, this is the biggest angle, he's got the biggest guy, this is second biggest, he's the smallest. Idiot check works, so I'm gonna go with that answer. Okay, so that's a pain in the backside, but that's what we have to do. 22. That leaves plenty of room for people to get the wrong answer, right? Yeah. All right, so we got this triangle, and we got 41, 36, 18. Right there. We're going to call it B, even though it doesn't call it B in the problem, we're still going to call it B. And this 2, 6, 7, 5. And over here we have 2, 1, 4, 5. And we're going to call this T, because the problem, why would they do that anyway? R. And we want to find little, call this guy S. We're going to find little t. Okay, so that's what we want to do. We still have to do everything, so it really doesn't matter. So I've got 2,675 divided by the sine of 41, 36, 18 is equal to 2,675 divided by, that's the same answer. Can't be right. I agree, it can't be right. 2145 divided by the sine of r. Oh, there we go. Now I got it. R is equal to the arc sine of. Alright, so the arc sine of 2,145 sine of 41, 36, 18 divided by 2,675. Alright, so now I can find R. 2,145 divided by 2,675 times the sine 41 math, degrees, minutes, and seconds, degrees, 36 math, degree, minutes, and seconds, minutes, 18 math, degrees, minutes, and seconds, seconds, close parentheses, boom. Well, it would appear I forgot to take the arc sine of this. Wasn't that brilliant of me? Arc sine of the answer. Alright, so I got 31.17 degrees, which I'm going to change to degrees, minutes, and seconds. So I'm gonna write down.
I got 32.17.
Yeah, 32.17, that's correct. So I'm going to write down 32, and then I'm going to subtract 32 from my answer and multiply my remainder by 60. And I'm going to write down 10 minutes. And then I'm going to subtract 10 from my answer and multiply by 60. And I'm going to have 12 seconds. So that's my answer. I'm sticking with it for R. So that's my answer for R. And now I've got to find T, right? All right, so I need the angle T. Oh, bummer. Okay, so I'm going to go with 180 minus 41 math, degrees, minutes, and seconds, whatever degrees, 36 math, degrees, minutes, and seconds, 18 math, degrees, minutes, and seconds, minus, now should I go with 32.17? I am. 32.17. Excellent. So I get my R is going to be 133.2 degrees, and that's probably close enough, so I'm going to use it. T, little t, t divided by the sine of 133.2 degrees is equal to R, 21.45 divided by the sine of 32.17. And then we don't have to worry about the degree, minute, second things, and I come up with my T, 21.45 times sine 133.2 divided by sine. No, I need a parenthesis there, divided by sine 32.17. Looks like my T is 2967 meters, and that should be good enough. Okay. So in the next set of problems, there is the possibility of there being two answers. Isn't life wonderful? So now we're in section 11.2, and we're saying, well, there could be, if I know something, I could have two answers. I could have one going this way, one going that way. The picture wouldn't look like that. But if I had something like this, and I knew that the side of my angle, then I could have an answer going this way, or I could have an answer going that way, right? If I knew this side, A, if I knew B, and I knew A, and I knew this angle here, A, then it's possible that I could have two different triangles, because that side opposite could swing either way. All right, so that's the issue. So we'll start with number 3. And we'll say, well, got a triangle, and the C guy is 26.5 degrees. And across from here is 42.7 kilometers. And the A guy is 47.2 kilometers. And here's B, and there's A. Okay, so I say, well, that being the case, 47.2 divided by the sine of A is equal to 42.7 divided by the sine of 26.5. clearly implying that A is the arc sine of, and so I got arc sine of 47.2 times, well, that was pretty bad, isn't it? Oh yeah, that was right. What am I doing? Arc sine 47.2 times the sine of 26.5 divided by 42.7, close parentheses, and I end up with 29 degrees. 29.6 degrees as my A. 29.6 degrees. All right. I know this side. All right, well, it doesn't look like I have an ambiguous case here, does it? Let me think. Yes, I could. This is the issue. The issue is the sine function comes up and comes down like that. So in the first quadrant, I have this 29.6 degrees. But in the second quadrant, I have another answer, 180 minus 29.6. So I've got 150.4 degrees as a second answer for A in the second quadrant. Now, because I have 26.5 degrees for C, I have two possible answers for B. So I've got a possible answer of B, 180 minus 26.5 minus 29.6. So B could be 123.9, or B could be 180 minus 26.5 minus 150.4. So B could be 3.1. And now I have two separate solutions I'm looking for. And this is exactly where Ben's going to not get his 100 on the next test, because he's going to fail to look for the second solution. Because his calculator is going to give him one, he's going to be happy with it, he's going to move on. So now we have two separate solutions. We have a triangle that looks like this. Looks like that, where this guy is 150.4, and then we have another triangle that looks like that, where this is 3.1. So we have two separate triangles we're looking for. Okay, so we have two different values of little b defined. Okay, so little b, if I'm doing the blue solution, then my little b over the sine of 150.4 has to equal 47.2 sine 29.6. And if I'm doing the purple solution, then B is going to have to be, B has to be the sine of 3.1 is equal to 47.2 over sine 29.6. So I have two separate solutions I'm looking for. But it all has to do with the sine function. Your calculator only gives you an answer in first and fourth quadrant for sine, and there's a possibility of a second quadrant answer. Okay, so the blue solution, 7.2 times sine 150.4 divided by sine 29.6 is going to give you, oh, isn't that lovely? 27.2, and we're in kilometers. And the purple answer is going to be 47 point. Everything can't be 47.2, can it? How can the B guy be 47.2? He can't be. This is not an equilateral triangle. Alright, so what did I do wrong? Alright. 47.2 times the sine of 105.4, close parentheses, divided by the sine of 29.6. Boom. 47.2 kilometers. Impossible. Unlikely. We'll try the second
I
one.
have B as alternate 3.9.
This guy?
No, B. The angle B.
As what? 150?
123.9.
Oh, you mean this guy here?
Yeah.
That's what I'm supposed to be using?
Yeah, you use.
Yeah. Alright. That solves the problem. It's I can't see the whole problem because I can't see the whole problem.
You didn't count it out.
Alright. 123.9. Is that better?
That's better.
Alright. Do you have an answer for B?
Yeah, well, I have one answer.
Alright, so I still have to do it. Times sine 123.9, close parentheses, divided by sine 29.6. Close parentheses. Okay, that's much better. So I got a 79.3 answer, or alternatively 47.2 times the sine 3.1 divided by sine 29.6. I have an answer that's 5.2 kilometers. So those are that. So I'd have two different answers, and seeing that we're not going to work another problem, we'd do in both of those cases we'd do a final answer. And what we're looking for is B. B and little b? No, A. We're looking for A, B, and little b. That's what we're looking for. So one of the answers would be 29.6. 29.6. 123.9. 123.9. And 79.3. And the other answer would have A equal to something, B equal to something, and little b equal to something. And this is the 150.4. And this is the 3.1. And the little b would be 5.2. Okay? But that's what we have to do. We do the same thing as we do in section 1, except now we're careful about the first time we solve for an angle, it might go either way. And therefore we have to look for the second quadrant answer as well. Isn't that lovely? I guess you can do the other two problems by yourself, right?
I do have a question though.
Yeah.
If the other answer, A was 150,
Yeah.
the line would be a lot bigger.
Yeah, it is.
right?
Yeah.
So,
No, this guy here would be the same. He'd just be the biggest one. And then this guy here would come way down small.
cause like we're given side C and side A,
Yeah.
and they're pretty close, so wouldn't the angles be pretty close too?
Yeah, the problem is that then they are.
But when you change
Yeah.
A to 150, would that side be really big?
So when I'm changing A, so I'm changing A to 150. So my triangle, yeah, I'm changing A to 150. So this guy's going to go way over there. This guy's going to be way small. And now A is going to be 150. This is going to be 3.1. This is going to be whatever it is.
26.5.
Yeah, 26.5. Well, I can't see enough of the problem to comment about it. So
I'm not saying the math is wrong.
Yeah.
But, do you want both answers?
oh yeah, you have to have both answers. Yeah.
Okay. 'Cause,
So now the issue is number 3. A and C are going to be about the same. Now, A and C are going to be the same. So I'm going to have a triangle that looks like, I have a triangle that looks like that, or a triangle that looks like, what's my other triangle look like? 129 for, or a triangle that looks like that. So those are the two triangles that I'm looking at. One where B has a big angle, or where A has a big angle. The angle at C is going to stay the same. And these angles I'm going to calculate. So the side across to C stays the same length in both of those pictures.
Okay.
The side across from B changes,
As they change.
yeah, because A changes.
Okay.
Does that answer that question? Okay.
And the back of the book says you're right too, so.
Oh, bummer. Hate it when that happens. Total, that, the grad student makes so many mistakes. And if I agree with the grad student, I'm not happy.